Well, welcome back, pre-calculus students. This will actually be my third attempt at doing notes for today. The app has not been working, and so I've had to redo it twice now. We'll see if this third time is the charm. Let's hope so. All right, we are going into chapter 10. We are doing probability. Unfortunately, we're having to skip 9.5 just due to time constraints. It's actually one of my favorite chapters or favorite sections in the whole book, 9.5. But it's really cool in theory, and that's why I like it so much. But it's really not that important for calculus. It's not really important for calculus at all, or other things. So we are just going to skip it, even though it's really cool. And we're going to move into chapter 10. So we're going to start with 10.1 here and look at probability. So let's talk about what probability is. So we talk about the probability of A, that is some particular event occurring, is, and we're going to use this for our notation. So this is read as the probability of A, so we're talking about the likelihood of A happening, is going to be a fraction where the numerator is the number of ways that A can occur, and the denominator are the total possible outcomes. So basically what this is this has to be a number between 0, has to be greater than or equal to 0, and less than or equal to 1. Because something cannot occur more ways than the total possible outcomes, and it cannot be negative because the least that something could occur would be 0 possible ways. So basically, if something cannot occur, the probability is 0. There's no ways that it can occur. The numerator is 0, so we have a probability of 0. If something is guaranteed to happen, that means the number of ways it can occur is the same as the total possible outcomes. We have a probability of 1. So we're always going to be either greater than or equal to 0 or less than or equal to 1. All right, moving on. Let's look at the probability of two events happening. Probability of A and B. When we have this A and B situation, we multiply the probabilities of A times the probabilities of B. So we multiply the two probabilities together. If we have the probability of A or B happening, then we add up the probabilities of A and the probabilities of B. So we would add up those probabilities, corresponding probabilities in that situation. All right. So, looking here, let's look at some examples of how we're going to do this. Find the probability of the following. Tossing a coin 3 times and getting the same result each time. This situation is a good example of where we want to use a probability tree. So this is one method of determining probabilities. So what I do is when I do the same result, is I do a tree that is a picture of it. So the first thing I do is I toss a coin, and I've got 2 outcomes, heads or tails. I toss it again, and each one of those outcomes has 2 outcomes, heads or tails. And then I do it a third time, and once again, each one of those outcomes has 2 outcomes. So now what I have to do is I have to count up the number of ways that I could get 3 of the same thing. And notice there are 2 ways that could happen. If I follow this out, I could get heads, heads, heads. Notice there's only one branch of the tree that has heads, heads, heads. And there's another branch of the tree that has tails, tails, tails. So there's 2 different branches that actually have the same result 3 times. And then when I look at the total number of outcomes, notice the total number of paths that can be taken down this is represented by these here. That's the end of a separate path each time. There's 8 total paths. So that's 2 that have the same result each time, divided by the total number of paths, which are 8. So a 1/4 or 25% probability. And you should always include the fraction answer for sure, and it's a good idea to include the percentage as well. Okay, the next situation, this involves a teacher that you don't know because I wrote this down a while back. So this is choosing a sophomore from both my class and Mrs. Heidegger's class if there is a 10% chance from choosing one from my class and a 30% chance of choosing one from Mrs. Heidegger's class. So here we've got 2 separate things. We want them both to happen. So that's an and situation. So we will multiply. So we have 0.1 times 0.3. And so multiplying those together, we get 0.03 or 3%. So when we do the multiplication, we have to change those percentages to decimals, do the multiplication, get a decimal answer, and then change back to percent. All right, choice C, all right, problem C here, part C. Draw a queen from a standard deck. So that's a standard deck of cards. So we want to think, first off, we have to count up how many ways could I get a queen? Well, I hope that you all know that there are 4 queens in the deck. Okay, there's one for each suit. There's a queen of hearts, a queen of diamonds, a queen of spades, and a queen of clubs. And we told you before, on a standard deck, there are 52 cards. So there's 52 different ways that I could get a card, 52 different possibilities when I draw a card. Only 4 of them are queens. So it is 4 out of 52, which reduces to 1 out of 13, which if I go and get the percentage for that, that would be 7.69%. A little rule on percentages. You always want to go out to 3 digits of accuracy. So if your percentage is 10 or greater, you would go to 1 decimal place. If your percentage is less than 10, then you would go out to 2 decimal places. And finally, choice D is, or question part D is rolling a sum of 4 with 2 dice. So when we think, how could we roll a 4? Well, the possibilities are we could have a 1 and 3, or we could have a 2 and 2. But that's not 2 possibilities, because with a 1 and 3, there's 2 different ways you could get the 1 and 3. You could get a 1 on the first dice and a 3 on the second dice, or you could get a 3 on the first dice and a 1 on the second dice. With the 2 and 2, there's only one way you could get that. That's a 2 on the first and a 2 on the second. So there's actually 3 different ways I could get a sum of 4. Now, when it comes to the total different outcomes I could get, so if I got a 1 with my first dice, I could get a 1, 2, 3, 4, 5, or a 6 with the second one. If I got a 2 with the first dice, I could get a 1, 2, 3, 4, 5, 6. So notice 6 different possibilities for the first times 6, because there's 6 for each of those possibilities with the second. And if you remember your multiplication principle, that would be a 6 times 6 situation, or 36. So that would reduce to 1/12, or if we gave it as a percent, 8.33%. So your homework is 1 through 22, all of them. Those will go rather quickly, and so I don't think that should be too difficult for you. And so we will finish up with 10.1 tomorrow.